Hi, this is Sonia Doucette. In this video, I'll show you how to calculate the standard free energy change using standard enthalpies of formation and standard molar entropies, which are two values that you'd look up in a table. For this problem, you're asked to calculate the standard free energy change for the dissolution of ammonium nitrate at 25 degrees Celsius using standard enthalpies of formation and standard molar entropies. So the reaction for the dissolution of ammonium nitrate will be NH4NO3 solid dissolving to give ammonium and nitrate cations and anion in aqueous form. So you can use this relationship, delta G equals delta H minus T times S, to find the standard free energy change, which is this value. But in this case, if you're using the standard enthalpies of formation and the standard molar entropies to find the standard free energy change, then you need to first calculate the enthalpy of reaction and the entropy of reaction. So this is what you use the standard enthalpies of formation and the standard molar entropies for. So in the first case here, to find the enthalpy of reaction, you take the sum of the enthalpies of formation for the products, and you subtract from that the sum of the enthalpies of formation for the reactants. So the values that you're going to look up in a table then are the standard enthalpy of formation for one of the products, which would be ammonium in aqueous form, and you're going to add that to another value that you'll look up, which is the standard enthalpy of formation for nitrate, also in aqueous form, and you're going to subtract from that the standard enthalpy of formation for your one reactant, which is ammonium nitrate solid. So when you look up those three values in a table, what you'll end up with is negative 132.5 plus negative 207.4 minus a negative 365.6. And when you do the math here, you'll get a value of 25.7, and that value will be in kilojoules. So there is the value for your delta H for this equation. The other thing you need to do is find your delta S value before you can plug that value into the equation. So you do something similar for delta S. So delta S naught is equal to the sum of the standard molar entropies of the products minus the sum of the standard molar entropies of the reactants. So what you'll get here is the sum of the standard molar entropy of ammonium in aqueous form plus the standard molar entropy of nitrate, also in aqueous form, and you're going to subtract from that the standard molar entropy of ammonium nitrate in solid form. When you look up these values in a table, what you'll end up with is 113 plus 146.4, subtracting from that 151.1. And when you do the math there, what you're going to end up with is 108.3, and the units here are in joules per Kelvin. So now you've got your delta H naught value and you've got your delta S naught value. So you can take those two values and substitute them into your original equation at the temperature of 25 degrees Celsius in order to solve for delta G naught, or the standard free energy change. So again, your equation is delta G naught is equal to delta H naught minus temperature times delta S naught. And you've just solved for these two values. The other thing you have to do is to take that 25 degrees Celsius and convert it to kelvins. So you add 273.15 to 25 degrees Celsius, and you're going to end up with a temperature of 298.15 kelvins, and that's what you'll substitute into this equation here. The other thing you need to do is convert your delta S value to kilojoules per Kelvin so that it's in the same units as your delta H value, which is in kilojoules. So all you do there is you multiply this value by the conversion 1 kilojoule per 1,000 joules, and you'll get a new delta S naught value of 0.083 kilojoules per Kelvin. So this is what you'll use in your equation. So substituting in these numbers, your delta H naught value is 25.7 kilojoules, and you're going to subtract from that your temperature of 298.15 kelvins multiplied by 0.1083 kilojoules per Kelvin. When you do the math here, what you're going to end up with is a value of negative 6.59 kilojoules. So there is your standard free energy change, or your delta G naught. And from this value, you can determine the spontaneity of your reaction. So when delta G naught is negative, the reaction is spontaneous, and that is what you have in this case. You have a negative number. So your reaction will be spontaneous.